Alright, last example, example 4. We've got a couple of ones we need to factorise here, which are a little bit harder. But once you see how we do them, I don't think you'll find them too bad. Now the first one, we've got 7a to the power of 3, 4a to the power of 5. Now the 7 and the 4 we can't do anything with because there isn't a number that goes into 7 or 4. So they're going to have to stay inside the brackets. We are going to look at the a cubed and the a5. Now what are we going to do with that? Well, I'm going to first recognise that a5 can come from a cubed times a squared. Okay, so you can write it like this if you want to: 7a cubed plus 4a cubed times a squared. Now you've got this term and this term you need to factorise. So what's common between those two terms? Very simply, the a cubed. So we've got a cubed at the front of the brackets. Inside we have got a 7 from here, and we have got from here a 4a squared. Now I forgot to tell you this earlier. You should never get these ones wrong, because quite simply you can quickly do an expansion to see if you can get the original question. Okay, so if we do a quick multiplication here, let's see what we get. We get a cubed times 7, which is 7a cubed, and then we have a cubed times 4a squared. Well, if I write the 4a squared there times the a cubed times the a squared, you add the indices, so we end up with 7a cubed plus 4a to the 5. Okay, so that means yes, it is correct. Alright, now let's look at this one, which is by far the hardest one that we've actually looked at, but again, it shouldn't be too bad if we can pick out what's common. Let's deal with the numbers first. We've got 12 and we've got 15. So the number that goes into 12 and 15 is of course 3. So I can put a 3 at the front. Now let's look at the p's. I've got a p squared and a p. Well, I can't get a p squared from here. I can get a p from here, so p is going to be common. And here I've got a q cubed and a q to the power of 4. I know I can get a q to the power of 3 from over here, so I'm going to write down here a q3. That's what I'm pretty sure my outside term is going to be. Now let's see what our brackets are going to look like. I'm going to write down here 3p cubed times something equals 15p squared q3. Now what do we need? Well, 3 times something gives us 15, so we need a 5. We've got a p here, a p squared in our answer, so we do need a p. And we've got a q cubed here and a q cubed in our answer, so we don't need anything there because they're just the same. So my front term is going to be 5p. Now let's look at our second term. We've got a minus 12p cubed to the 4. Okay, let's deal with our number first. We've got 3 times something gives us minus 12. 3 4s are 12, so it's going to be 3 times minus 4. Right, let's look at our p. We've got a p in our question, we've got a p in our answer, so we don't need a p at all. Look at our q's. We've got a q cubed here and a q to the power of 4 here. If I multiply our q cubed by another q, that'll give us a q to the power of 4. Because a q by itself is with a power of 1, and if we add those indices together, we get a 4. So this term here is our second term, minus 4q. Now, if you want to do a quick check, let's multiply it out and see how we go. Let's do it just over here. 3 times 5 is 15. P times P is P squared. The Q3 will end up being on the end. Look, it checks out. And our last term, got a minus. 3 times 4 is 12. The P stays. And we got a Q3 times a Q, which is Q to the power of 4, which is what we had here. So yes, this is our answer. Alright, let's finish off the set. See how you go.